In this video, we will be looking at problems from permutations and combinations and binomial theorem. So there are five problems, I think, yeah, five that were being asked in this August 4, 21 shift 1. So let us try to solve them one by one. So this is the first problem. 34C5 plus sigma r equals to 0 to 4, 38 minus 4C4. Let us first try to expand this expression. What do we have? 34C5 plus, when r is 0, 38 minus 0 is 38, C4 plus r is 1, so 38 minus 1 is 37. When r is 2, it is 36. When r is 3, it is 35. When r is 4, this is 34C4. Now I have to see what this all will be equal to among the four of these. So we cannot just start by like doing 34 factorial by 4 factorial, 30 factorial, 35 factorial by 31 factorial, 4 factorial. It will take 10 minutes, and by the time the exam is done, and you would have solved like 10 questions. That's it. So we know that NCR minus 1 is equals to n plus 1 CR, right? Everybody knows this formula. So if I look at where is r minus 1 and r in this, all of these are 4, but this is 5, right? So if I look at 34C4 and 34C5, 34C5 plus 34C4, you can say n equals to 34 and r is equals to 5. So r minus 1 will be 4. So this should be equal to n plus 1. N is 34. So 34 plus 1 C, r is what? 5. 35C5. So that expression reduces to 35C5 plus what? 38C4 plus 37C4 plus 36C4 plus 35C4. Now we will combine these two. 35C5 plus 35C4, what will this be? This will become 36C5, right? 36C5 plus 38C4 plus 37C4 plus 36C4. Now we combine these two. What will you get? 37C5, right? Now the combination of these two, 37C4 plus 37C5, of course, this will be 38C5. And when you combine these two, what do you get? 39C5. So this one. So that's it. The first problem was easy. You just have to remember to use this formula and don't start solving all of these individually. Otherwise, you will waste a lot of time. Now, second problem. 22p r plus 1 is to 20p r plus 2 is 11 is to 52. What is r? So let us just use the formula, right? 22 factorial by 22 minus r minus 1 factorial is to 20 factorial divided by 20 minus r minus 2 factorial is equals to 11 is to 52. Or we can write it this way, 22 factorial by 22 minus 1 is 21 minus r factorial. Since this is 2, so reverse it. So 20 minus 2 is 18 minus r factorial divided by 20 factorial is equals to 11 by 52. Now let us expand this. 22 times 21 times 20 factorial. This is 18 minus r. If I have to expand this, 21 minus r, 20 minus r, 19 minus r. Okay, now I got 18 minus r factorial. by 20 factorial is equals to 11 by 52. This is cancelled and this is cancelled. So now what do we have? We have 22 times 21 by 21 minus r, 20 minus r, 19 minus r is 11 by 52. Now if you open these brackets and try to solve it, you will get a cubic equation. R cube term will be there, r square r term will be there, and when you try to solve it, again you will waste 10 minutes. So I don't want to do it that way. So what will I do? 21 minus r, 20 minus r, 19 minus r is equals to 22 times 21 times 52 by 11. Okay, so this is 2. So 2 into 21 into 52. Now if you look at these are 3 consecutive numbers, right? If I subtract 1, I get 20 minus r. Subtract 1 again, I get 19 minus r. So this product of 3 consecutive numbers. If I convert this into 3 consecutive numbers, I can easily get the value of r by comparison. So let us do that. 21 is 3 times 7. What is 52? 4 times 13, right? So let us try to make it a product of 3 numbers, 3 consecutive numbers. So if I do 2 into 7, I got 14. 3 into 4, I get 12, and 13 is already there. So this is like 14 times 13 times 12, which is 21 minus r, 20 minus r, 19 minus r. So by comparison, r is equals to 7, right? 19 minus 7 is 12, 20 minus 7 is 13, 21 minus 7 is 14. So we are done. R equals to 7. Okay, let us look at third problem. The value of the numerically greatest term in the expansion of this when x equals to half and y is 1 by 3. So we know that we can expand it like 11c0 2x raised to the power 11 3y raised to the power 0 plus 11c1 2x raised to the power 10 3y raised to the power 1, right? We can go on and on up till 11c11 2x raised to the power 0 3y raised to the power 11. Now he's asking which of these terms will be the greatest term, like this term or this term or this term or the ones in between when x equals to half and y equals to 1 by 3. Now notice if I put x equal to half, then 2x is what? 1. If I put y is equals to 1 by 3, this is 3y will be 1, right? 11c1, 2x will be what? 1 again because x is half. 3y will be what? 1 again because y is 1 by 3. On and on. 11c11. 2x will be 1 again. 3y will be 1 again. So all these terms are just 1. This is 1. This is 1. 1 product. 1 multiplied with 1 is also 1. So for this condition, x is half and y is 1 by 3. The expansion is just this. 11c2, 11c3. 11c4, 11c5, 11c6, 11c7, 11c8, 11c9, 11c10, 11c11. Now we know that this is 1, this is 1, this is what? This is 11, this is also 11. This is what? 11 times 10 times 9 factorial by 2 into 9 factorial. So this is 55. This is also 55. So you can see that the value of these coefficients first increases and then it decreases, right? This is equals to this is equals to this, and this is equals to this. So 11c5 and 11c6 are equal to each other and they are the maximum values. It increases from 1 to 11 to 55 to this, to this, to this value, 11c5, which is the maximum, which is also equal to, so it is, graph is like this, 11c5, 11c6. These two are equal and then it starts reducing again. This is how these coefficients are increasing, then stays the same, then decreasing. So the answer is either 11c5 or 11c6. Very easy, right? We don't have 11c5 or 11c6. Let us try to expand it. 11 times 10 times 9, or just start with 11 factorial by 5 factorial. 11 minus 5 is 6 factorial. This is what we have to compute. So which is what? 11 times 10 times 9 times 8 times 7 times 6 factorial. 5 factorial is what? 5 times 4 times 3 times 2, and 6 factorial is already here. So this is cancelled. 5 times 2 is 10, so this is gone. 4 times 2 is 8, 3 times 3 is 9. So what am I left with? 11 times 3 times 2 times 7, which is what? 33 times 14. 33 times 14. 14 times 3 is 42. 14 times 3 is 42 plus 4 is 462, right? 462. This is the correct option. So when you try to see this, if you are able to see x is half and y is 1 by 3, so all these terms will be just 1. Then you realize the coefficients are just 11c0, 11c1, 11c2. And if you know their properties, you know that it is going to be maximum at here. Then you just find out the value and that's it, you're done. Okay, now next problem. The coefficient of x raised to the power 4 in the expansion of this 1 minus x square plus x cube raised to the power 6. So what I don't want you to do is first multiply this with this. Then you're thinking like, oh, okay, I have x square. Now I multiply it with this again, I will get x cube. Then again, then raised to the power 4, again 5, and then 6 times. Again, this will take more than 10 minutes, and this is not how to solve this problem, because you want to solve this as quickly as possible. What I'm going to do is take x square common, right? Very easy to see. I can take x square common. Then I can take 1 minus x common, right? 1 minus x. Over here I'm left with 1 minus x square. This is factorization from class 8, 9, 10th. We all know about this. This is 1 square minus x square. So 1 minus x into 1 plus x raised to the power 6. So this is 1 minus x whole square, 1 plus x. All of it is raised to the power 6. So 1 minus x raised to the power 12 times 1 plus x raised to the power 6. Now this is much easier to expand. When I expand this, I will get terms of 1x, x square, x cube, x4, x5, x6. This will go till x12. This will be like 1x, x square, x cube, x4, x5, x6. Now in the problem I am being asked the coefficient of x raised to the power 4. So I don't need to find this term or this term. And I don't need any of the terms more than x raised to the power 4. I will just ignore them. So let us first look at 1 minus x raised to the power 12. If I expand it, what do I get? 12c0, 1 raised to the power 12 minus x raised to the power 0. Right? This is how you expand. Everybody knows this. 1 raised to the power 11 minus x raised to the power 1 plus 12c2, 1 raised to the... I don't need to write this. I'm just writing it for your understanding. You can just ignore it because it's 1. So any power will be 1. It will stay the same. 1 raised to the power 9 minus x cube. 12c4, 1 raised to the power 8 minus x raised to the power 4. And plus dot dot dot, which I am not interested in because I only need the coefficient till x raised to the power 4. If I get x raised to the power 5 and multiply it with this series over here, minimum term would be 1. So still I will get x raised to the power 5, which is not useful to me. So I'm just ignoring all of this. Now what is this? This is 1. This is 1. This is 1. So just 1. Plus 12c1 is what? 12c1 is 12 and minus x. 12c2 is what? 12 into 11 into 10 factorial by 2 into 10 factorial minus x square is x square. 12c3 is 12 into 11 into 10 into 9 factorial by 3 factorial is 3 times 2 and 9 factorial minus x cube, right? This is done. 3, 6, 2. Plus 12c4 is 12 times 11 times 10 times 9 times 8 factorial. Since the options are all these numbers, none in the form of NCR, so I'm not going to keep it in this form either. I'm going to expand. 4 factorial is 4 times 3 times 2 and 8 factorial and x4, right? No minus sign this time. So this is 6. So what do I have? 8 factorial gone, 4 times 3 is 12 gone, 2 times 5 is 10 gone. So 1 minus 12x plus 66x squared minus 22 times 10, 220x cubed plus 11 times 5 is 55 times 9 is what? 55 times 9, 495 I guess. Yes, 495 x raised to the power 4. One series is done, this one. Now I will look at 1 plus x raised to the power 6. I will go till x raised to the power 4 as well in this one. So 1 plus 6c1x plus 6c2x squared plus 6c3x cubed plus 6c4x4. I'm not worried about x5 and x6. 6c1 is 6, right? 6c2, what is 6c2? 6 into 5 into 4 factorial by 2 into 4 factorial x squared. 6c3, so 6 into 5 into 4 into 3 factorial by 3 factorial is 3 times 2 and 3 factorial x cube. 6c4 is just this, right? 6c2. 6 into 5 into 4 factorial by 2 into 4 factorial x4. This is cancelled, this is cancelled, this is cancelled. This is 3, this is again 3. 3 times 2 is 6, this is gone. So what I have here, 1 plus 6x plus 15x squared plus 20x cubed plus 15x4. So I have the two series. Now I just need to multiply and get the term for x4, right? So what are my two series? This is my first series. This is my second series. When I multiply these two, which is 1 minus 12x plus 66x squared minus 220x cubed plus 495x4 times 1 plus 6x plus 15x squared plus 20x cubed plus 15x4. I multiply 1 with this, I will get x4. So first term is 15x4. I multiply this with x cubed. So minus 12 times 20x4. This will be multiplied with this. So plus 66 into 15x4. This will be multiplied with this. Minus 220 into 6x4. This will be multiplied with this plus 495x4. So this is the term for x raised to the power 4 in the expansion of the given series. I take x4 common. I don't want to write it again and again and again. 12 times 20 is 240. 66 times 15 is what? 60, 15 times 6 is 90, so 900 plus again 15 times 6, so 990 x4. x4 not here, it's taken over there. So 22 times 6 is 132 plus 495. A lot of work. 15 plus 495 is what? 510. 510 and 990 is what? 600 plus 900, 1500 minus 1580, I guess. Yeah. So minus 80 x4. So what is the coefficient of x raised to power 4? Minus 80. Okay, I think I made a mistake over here. Sorry, 1560. 40 and 20, 60. So minus 60 x4. So minus 60 is the correct answer. Let's move on to the next problem. The sum of coefficients in the expansion of 1 plus x by 2 raised to the power 12. This question should not take more than 5 seconds. Why? Just put x equals to 1 in this. What do you get? 1 plus 1 by 2 raised to the power 12, or 3 by 2 raised to the power 12 is the sum of the coefficients. If you are doubting yourself whether this thing works, let us look at one simple 1 plus x whole square. If we know that this is like 1 plus 2x plus x square, we can write it as x raised to the power 0 into 1. So the sum of all the coefficients here is what? This is 1. So 1 plus 2 plus 1. Sum of all the coefficients is 4. If I put x equals to 1 here, what do I get? 1 plus 1 whole square. 2 square. This is 4. Again, if I want to find the sum of the coefficients in the expansion of say 1 plus x cube, let us see. How do you expand this? A cube, 1 cube is 1 plus b cube plus 3ab, 3 into 1 into x is 3x into a plus b, or 1 plus 3x square plus x cube. This is x raised to the power 0. So sum of all the coefficients is what? This is 1. 1 plus 3 plus 3 plus 1, which is 8. If I put x equals to 1 here, what do I get? 1 plus 1 cube is 2 cube. 2 cube is what? 2 times 2 times 2. 2 into 2 is 4. 4 times 2 is 8. So this formula works. Just put x equals to 1 into this and it's done. So we are done with the problems on permutations and combinations and binomial theorem. See you all in the next video. Thank you, everyone.